Question number 16. He wants to know the change in temperature. The change in the temperature is simply equals Q over the specific heat capacity times the mass. In this case, the Q equals the kinetic energy, as there's no change in the potential energy because there's no change in the height and the acceleration, and the mass is constant. So it is half mv square over the specific heat capacity times the mass. M and M cancel, so it is half v square over the specific heat capacity. He gave us the specific heat capacity in the unit kilocalorie per kilogram degree Celsius, so we wanted to convert this unit to joule per kilogram degree Celsius. So the specific heat capacity equals 0.0305. To convert it to joule per kilogram degree Celsius, we have to multiply it by 4186. So the result will be this number, 127.67 joule per kilogram degree Celsius. Okay, let us substitute in this rule. V square, which is half V square, which is 240 power 2 over the specific heat capacity, which we just calculated. All this equals 225.57 degrees Celsius. But in the question he said half of the energy, half of the resultant heat energy. Okay, so we will divide this number over 2, which will be approximately equals 113 degrees Celsius. So the answer is A. Question number 17. Very easy question. He asked about the kilowatt hours of energy are required. So let us calculate the energy in the normal way. Q equals the specific heat capacity times the mass times the change in temperature. Okay, the specific heat capacity here is 4186 times the mass, which is 3.8 kilogram, times the number of gallons, which is 40,000, times the change in temperature, which is 10. All of this equal to this big number, joules. Okay, now we calculated the energy. We just have to convert it to kilowatt hour. The conversion factor from the joule to kilowatt hour is dividing the joule over this number. Which is approximately equals 1770 kilowatt hour. If you want to know where this conversion factor came from, I will leave a link in the description box. I recommend you to see it to understand where this conversion factor came from. Question number 18. Very simple question. M is simply Q over the specific heat times the change in temperature. Q here is 5.4 times 10 to the power 7 over the specific heat capacity, (0.21). But he said in the unit of which he gave us in the question is calorie per gram degree Celsius. We want it to be calorie per kilogram degree Celsius, so we will multiply it by 1000 times the change in temperature. The change in temperature 62 times 20. All of this equals approximately 6122 kilogram, which is approximately equal 6100 kilogram. So the answer is C. Question number 18. Sorry, question number 19. Okay. He wants to know the change in temperature. The change in temperature simply the basic rule, the Q over M, Q over the mass times the specific heat capacity. Q here we all know equals the kinetic energy plus the potential energy. Here there's no potential energy because he said what is the temperature increase at the bottom of the incline. At the bottom the height is 0, so the potential energy and the change in the potential energy equals 0. So it will be the kinetic energy, or the change in the kinetic energy. As you all know that the change in the kinetic energy equals the work done, and the work done equals the force times the distance, and as it is an inclined plane, times sine any symbol times sine alpha. Alpha here is 30 degree equals the force here is the mass times the gravity times sine the same angle alpha times displacement. The mass here is 0.2 kilograms times the gravity, which is 9.8, times sine 30, which is, I think it's half, times displacement, which is 15. All of this equals 14.715 joule. He says in the question, if 90% of the mechanical energy of the system is absorbed by the aluminium, so we will consider or deal with the 90% of this number. Which is equal to 13.24 joule. So let's go and calculate the change in temperature. Q over M times the specific heat times the specific heat. Let us write it another time. Ninety percent of the energy, which I just write it, which is 13.24 over the mass, which is 0.2 kilograms, times 90, which is the specific heat capacity. Let me make an arc. All of this equals 0.073 degrees Celsius. So the answer is B. Question number 20. Delta T, he wants to know the change in temperature. Delta T is simply equal or let me write it another way. Q equals MC times the change in temperature. Okay, in this case, Q is the potential energy. As he said in the question, the initial potential energy goes into heating the water. So Q here is the potential energy equals mgh. M and M cancel. So we have that delta T equals GH over C, which is a specific heat, equals G is 9.8 times the height, which is 145, over the specific heat, which is 4186. So the answer will be 0.34 degrees Celsius. So the answer is B. Question number 21. He wants to know the change in temperature. Okay. First, let's start with calculating the energy or the work done. he gives us the power and the time, so we can calculate the work done. Power simply equals work done over the time. That means work equals the power times the time. The power here is 800 times the time, which is 10 minutes. 10 minutes times 60, which is how many seconds in a minute. All this equals this number. Okay. Here we calculated the Q. W here is equals Q. So delta T equals Q over the specific heat capacity times the mass. Q is the work done over the specific heat capacity, which is 4,186 times the mass, which is 4 kilograms. All of this equals approximately 29 degrees Celsius. Question number 22. The solar radiation or the intensity equals the power over the area. So to calculate the power, let me write it. Solar equals power over time. Sorry, power over area. So if you wanted to know the power, we have to power equals solar radiation times area. The solar radiation they give us in the question equals 1,000 times the area, which is 4 meter per second, meter square, equal to 4,000. So this is the power. And we all know power equals work over time. So simply work equals power times time. We just calculated the power, which is 4,000, times the time, which is 1 hour. 1 hour equals 60 minutes times 60 seconds. So this is the work, which is this number. Joule. Q is simply equal to the work. So let us calculate the change in temperature. Equals Q over the specific heat capacity times the mass, equal to this big number over the specific heat capacity, which is 4,186 times the mass, which is 30 kilograms. All of this equal this number, 100 and 40.6 degrees Celsius. But he said in the question, a solar heating system has 25% conservation efficiency. So 25 of this number equals simply 28.7 degree Celsius. So the answer is C.